Welcome back. In this video, we are going to revisit our learning on cost curve and we will apply our learning to obtain supply function of a firm, supply function of a business. But first, let us do recap what we had already learned. We had figured out that how do we obtain the cost function? By minimizing the cost of inputs such that the firm is able to at least produce y unit of output. And this we have obtained that if we do the cost minimization, the optimal cost is going to be C as a function of W1, W2 and Y. So when we are talking about cost here, we are talking about not just any random cost. We are talking about the optimal cost required to produce Y unit of output such that prices of inputs are W1 and W2 respectively. So that we have to keep in mind. Now think of the entrepreneur who is running the firm. Let us say he is small enough in comparison to the whole market so that he is not able to influence the prices W1 and W2. So he buys inputs from the market at W1 per unit for input 1 and W2 per unit for input 2. So basically then his cost depends on how many units he want to produce. Earlier we had used C of Q where Q indicated the amount of output. Both are valid. We use Q as well as or Y as variable to indicate the level of output. And then we said that C of Q is equal to fixed cost plus variable cost, and variable cost varies with Q and therefore it is a function of Q. Fixed cost does not depend on output, so it is not a function of Q. And we had obtained that average cost is equal to average fixed cost, a function of Q, plus average variable cost. And then we had gone to the graph and we had said that average fixed cost is always falling. And then we had also talked about average variable cost and we had said that average variable cost could be fixed, it may not be changing, it could be increasing, it could be decreasing. All these possibilities are there. In fact, even more, that in some range it remains fixed, in some range it goes up and the remaining range it goes down, even the mix of it, everything is possible. So, but typically we will assume that, let us say that if we say that average variable cost is increasing, and just for example I am taking, you can take another example, we will take average variable cost like this. So we will obtain average cost, first it goes down and then it goes up like this. Why it goes down first? Because average fixed cost effect dominates the average variable cost effect, and later on average variable cost dominates average fixed cost. So in beginning it is guided by average fixed cost and later it is guided by average variable cost, and this is the way it looks like. Further we had obtained that average cost, how does it vary with quantity, and we had obtained and we had said this is also equal to average. You will get exactly the in both cases you will get the marginal cost. So we will use only one of them because, and so let us remove this and say this is going to be equal to 1 by Q marginal cost minus average cost. If we had used this one, let me write here DAVC by DQ, then we will get 1 by Q MC minus AVC. That is what we will obtain, and that is why I said let us not put it here together, although this is also the definition of marginal cost, this is also the definition of marginal cost. And so we had figured out that if MC is greater than AC, it means average cost is increasing, and if MC is less than average cost, it means average cost is falling, and if MC is equal to AC, then at that place AC remains stable. Exactly the same thing can be written with respect to your average variable cost. If MCA is greater than AVC, then AVC is increasing, and so on, that you will have exactly the same thing. So, let us look at, let us put here average variable cost rather than just average cost. And so, if we do this, what we have, the graph that looks like and something like this. So, here let us say it attains minimum, and here is average variable cost, and here is Q. So, as we see in this zone, average variable cost is falling. Let us say average variable cost is falling. What does it mean? That in this zone MC marginal cost happens to be less than average variable cost, and this is another zone in which AVC is increasing. So, in this zone marginal cost has to be greater than average variable cost. And so, we will go further and try to see what happens. Of course, we get the trend that where marginal cost is lower than average variable cost and where marginal cost is greater than average variable cost. But if we can pinpoint a relationship at a particular point between marginal cost and average variable cost, it would help us draw. So, let us see what happens at marginal cost to produce one unit and in very beginning. So, the output is moving from 0 to 1. So, rather than saying equal, we will say almost equal, because we know this definition is not correct. This is total cost to produce 1 unit minus total cost to produce 0 unit. And so, this can be written as fixed cost plus variable cost to produce 1 unit minus, we can say, fixed cost, because nothing is being produced here. So, there is no variable cost there. So, this fixed cost will get cancelled, and we can say this is equal to VC1. So, marginal cost at 1 is almost equal to variable cost to produce 1 unit. If we want to be more accurate, we can use calculus definition. We can say how much is the marginal cost at 0. We can say that is limit h tends to 0, because we have to look at its vicinity 0 to h we are going. What's happening is the total cost to produce h unit, h is a very small number as it's indicated from here, minus total cost to produce 0 divided by h minus 0. And here also we will get limit h tends to 0 Vc to produce h unit divided by h unit, and this can be written as limit h tends to 0 average variable cost to produce h unit, and therefore, it is equal to, we can say this side move in this direction, this is basically average variable cost to produce 0 unit. So, in very beginning, if we go like this, at this particular point, if we use a different colored to indicate marginal cost at this point is going to be equal to average variable cost. So, and because in this zone marginal cost is smaller than average variable cost. So, we can say something like this, and here it crosses and it goes up. This is the marginal cost and this is the average variable cost. Okay. So, that we have to keep in mind. Let us explore the further relationship between MC and AVC. So, we can, as we have written approximately, that MC1 is equal to VC1. How about MC2? MC2 is going to be equal to TC2 minus TC1. And what is TC1? TC1 is, we can write, or we can leave it like this, or we can, here also we can write TC1 minus TC0, and MC3 is going to be TC3 minus TC2, and so on. MCN is going to be TCN minus TCN minus 1. If we add all these on this side, we will get sum of MC, let us say I, where I goes from 1 to n, and on this side TC1 will get cancelled from here, TC2 will get cancelled. So, what we will left with is TCN minus TC0, and that is, we can write FC plus VC, or let me put here summation of MC i's is equal to TCN minus TC0, and this is FC plus VCN minus FC minus VC0, and VC0 is nothing, so it's equal to 0. FC will get cancelled. So summation MCI roughly gives you VCN if I varies from 1 to n, and you can do it using calculus also, that gives you much more accurate result. MC is equal to D, we can say dVc by dq. So if we write it like this, dVc, let us say here it's for q, MC dq, and if we integrate, we will get Vc q minus Vc 0, which is nothing, 0, is equal to nothing but MC dq from 0 to n, or 0 to q, and that's what we will obtain. This is of course way more accurate. What does it mean? That if MC curve, the area under the curve we integrate from here, let's say 0 to this point, or any point for that matter, we will obtain how much is the variable cost till this point, okay. And so that is the relationship that we have obtained. Now let us write cost curves in short run. Short run, why? Because we are talking about as we have already fixed cost. In long run, we will not have any fixed cost. But remember, in very beginning I mentioned three kinds of cost: fixed cost, quasi fixed cost, and variable cost. And we said let us not pay attention to this. But even in long run, sometime you will see fixed component, and that fixed component could be because of quasi fixed cost. So then don't worry about it, why we are getting fixed component in total cost curve. Because of the presence of quasi fixed cost, you can have that component. So we have all the information to give you all average cost curves. Let us say this is the way Q is varying on x axis, and let us say this is your average variable cost. This is your marginal cost. You can also draw, let us say it could be, in dotted line I am drawing, this is average fixed cost curve, and we can also bring the average cost curve. It's going to be sum of average variable cost curve and average fixed cost curve. So it can start something like this. At this point we should not give at 0, because and as we increase Q, average cost asymptotically, or we can say average variable cost should asymptotically touches average cost curve. What it means? Because for very high AFC will go to 0. For very high output, AFC is tending to 0. So ultimately they will become the same. Notice that marginal cost curve cuts the average variable cost curve as well as average cost curve. In red color we have average cost. So we can say that this point as well as this point, that's a minimum of, it goes through the minimum of average cost curve as well as average variable cost curve. So these are the cost curve in short run that we are talking about. That should be clear to you. Now in the next slide, we have started profit maximization. In fact, we have space here, we can do it. So for profit maximization, what you have is basically you want to produce Q output, okay, at minimum possible cost. So profit maximization already include cost minimization. Your profit is total revenue minus total cost, and if a firm is price taker, it means firm is not able to control the price of output. Whatever price in the market is there, it has to take it at, and let us say that market price is P. How many units should it sold? C of Q, and that is the maximization it has to do. And the first order condition we had already figured out, that marginal revenue has to be equal to marginal cost. So we can say if we do this maximization, and of course we have to do with respect to Q, this, the first order condition is going to be P minus MC of Q is equal to 0. Or in other word, we can say Q is nothing but it's a function of P. So how many unit a firm should supply? It should depend on its marginal cost. That's what we have. So basically what we are saying is that, when we are doing the supply function, right at the beginning I told you that we have these two axes. On y axis we have P, on x axis we have Q. We get an upward sloping curve typically for the supply function. How do we get it? I gave you some heuristic logic, that if price is higher, someone who was willing to supply 5 units, perhaps he can supply more units because he can spend more time. Even if it is costlier, he is willing to get that higher price in the market, so he would be willing to supply more. But it is basically coming from here, okay. So what we can say, that rather than having P versus Q, we can do MCQ versus, let me write here, MC versus Q. And this is what we are doing. If you pay attention to this expression, that expression is that P as a function of Q, and that function is coming from MC, and that's the way we are drawing. When it comes to supply function, rather than drawing Q as a function of P, we are drawing P as a function of Q, and that function is coming from marginal cost, and that we have already obtained. Where is that? In black color. This is the MC curve, so I can draw it like this. But the issue is that if we say MC is equal to P here, at this particular price there are two labels. Which label one should use to produce, whether this label or this label? In one of the earlier videos we have already resolved this, that we should be taking the higher number, we should be taking the output that lies on the upward sloping part of the marginal cost curve. So what we get first, if we want to get the supply function, we have to look at the marginal cost function. That's the first thing. So let me write here for supply function obtain the marginal cost function. That is the first step. The second step is discard, so retain only the upward sloping part of the supply function. That is the second stage. So, let us look at the upward sloping part of the marginal cost curve, and it is here. So, we take all. Let us also consider one more thing. When we did the profit maximization, we varied the Q, the output. We did maximum of PQ minus CQ, and we talked about how much of Q to use to maximize the profit, but we missed one particular point. What if we don't produce anything? So, let us say that this formulation says that you produce Q star. So, you have PQ star minus CQ star. The other option is also to produce nothing, and when you produce nothing, how much is going to be your total revenue? 0. You are producing nothing. How much is your cost? Just the fixed cost. So, this entity should be greater than or equal to, also we can say, fixed cost. So, we can write here PQ star minus fixed cost minus variable cost to produce Q star should be greater than just the minus of fixed cost. So, this will get cancelled. So, in other word, PQ star, the revenue that you are getting from the market, should be enough to cover your variable cost. So, it should be greater than variable cost, and so it means P should be greater than average variable cost. So, if we have P here, let us look at it P here. What is the marginal cost? Marginal cost is this much, and how much is at this particular Q? How much is the average cost? Average variable cost is higher than P. So, we cannot use this particular upward sloping part. So, we have to use only this part of the marginal cost curve. So, two rule we have already written, that for supply function obtain the marginal cost function. Second, we have said retain only the upward sloping part. Third, we say that go further and retain only that upward sloping part that lies above the average variable cost curve. So, these three rules can help you obtain a supply function of a firm. With two disclaimer, that this firm takes input prices as well as output prices as given. So, that is it for this video. Thank you.